Hello all, welcome to our webinar on how to build an Arabic-English bilingual medical LLM with seamless interaction capability. This is Hisham Cholakkal from Mohammed bin Zayed University of AI. So this presentation is based on our project here at MBZUAI named BiMediX. I would like to thank my team and collaborators for their contribution to this project, namely Sarah, Sahal, Irfan, Fahad, Rao, Salman, and Tim. Whenever we go to a hospital, normally the doctors ask, questions about our disease, right? Like say, normally they ask you to explain your disease, and based on your explanation, he's going to ask you more about it, like to know more about your symptom, like say when the disease started, whether if it's a pain, whether how severe is the pain, and different things like that to better know about your symptom. And only after several iterations like this, or several conversation, a detailed conversation with you, he's going to understand better about your disease, and he's going to give you a suggestion, the right medicine suggestion for you, right? But like say whenever we look into the leading medical LLMs, right, they are really good on the medical benchmarks. But these medical benchmarks are multiple choice questions based, or basically they are based on the medical exams that are medical MCQ based one. And because of that, many of these medical LLMs lose the capability, to interact with the patient in this way, like, in this multi-turn conversations, right? And most of these medical exams, are tailored for English language that leaves the resource constrained languages like Arabic behind. So we have more than 400 million people talking Arabic language. Right? So that's kind of a huge gap, that need to be filled in. So in this work, we aim to address these limitations of existing LLMs by coming up with healthcare specialized LLM that can seamlessly, interact with the patient through multi-turn conversations, and it can at the same time it is good on state of the art. It's in fact state of the art on MCQ based medical benchmarks, and it can do this well in both MCQ based evaluations as well as in conversations in both English and Arabic evaluation, Arabic languages. So how we achieved this? We did to come up with through the three key contributions. So we come up with an evaluation benchmark for Arabic language, because you can see that most of the standard benchmarks, they are in English, and we don't have such evaluation benchmarks to benchmark the LLMs or the healthcare specialized LLMs in Arabic language. So we wanted to address this gap, and that's why we came with this Arabic evaluation benchmark. And the second issue is that we don't have sufficient training data to train healthcare specialized Arabic LLMs, right? Because we don't have enough resources or enough training data for that. So to address that, we also proposed, or we also introduced a data set, that has Arabic instructions. And now with this, we call this healthcare specialized English Arabic bilingual data set as BioMed 1.3 million data set. And with this data set, we have instruction tuned and to come up with an LLM that has this seamless conversation capability, and it's also doing well on the the benchmarks, evaluation benchmarks. So this is the overview of the remaining part of this talk. So I'll first introduce the benchmark, then I will also introduce the data set, and then I'll talk about the training of the model, and then we'll discuss about the results, and then different use cases we can use, and then I will show you a demo demonstrating the capability of our model. So as I said before, most of the medically reliable textbooks and benchmarks, they are in English language, right? So, and to be honest, we have very limited resources, in Arabic language that are medically reliable. So we wanted to address this gap, and a natural way of addressing this gap is like doing a simple translation, like using a Google Translate and to translate this text from English to Arabic, right? But the problem is that we found that translation quality is not that good or not that great while we use this kind of automated translation tools. So then the next step or next thought process is like, can we come up with a semi-automated translation pipeline that uses LLM along with the native Arabic speakers to come up with a good quality translation for application. So here is an overview of our semi-automated translation pipeline we use for our benchmarks. So let's say here the good thing is that we can use or we can translate both the question as well as the answer together with an LLM, right? So that's so here you can see the good thing, as I mentioned, since you are passing both the question and answer to the translator or to the LLM, it knows the overall context of the question and answer, and that kind of resulted in a relatively better quality translation. And also we have adjusted the prompts to the LLM in a way that to kind of improve the translation quality. So because right away once you take the English text and pass it to an LLM for the translation, it was not that perfect, but we then adjusted the prompts in a way like to give a translation that is in relatively a better quality. But then we have passed this translated text to the native speakers, and with the random checking, we have identified that it's even with this LLM-based translation, the quality of translation is not that good, right? So there's still scope for improvement. And so what we did is we have so now we need to identify which are the samples that are of bad quality translation, right? And then we need to improve the quality of those translations. So how to do that? How to automatically identify it, right? So then we used LLM again for that purpose. So what we did is we have paused this English text and the translated text to an LLM, right? And ask the LLM to score the translation quality in a scale range of 0 to 100, right? The 0 means very bad quality translation, 100 means a perfect translation, right? So now, while we have while we did it, the first iteration, we have seen that again, the scores what we get from the LLM is not that perfectly aligned with the way a human or the person rate it. There was a side misalignment. So with the help of native speakers, we by picking certain samples and then we aligning the scores or adjusting the prompts to the LLM in a way that we kind of get a score that is better aligned with the human intuition or human scoring to those translation quality was kind of achieved. And then we use that prompts for all the translations for the translation of the remaining questions. And that resulted as a relatively better, quality translation, better, scoring for all the translations, right? And then now we have the translated Arabic text and their corresponding score, right? And then what we did is the translations that are, let's say, scope below a threshold, they, that means that their translation quality is bad. All right. So we come up with this threshold again with the support of native speakers, and then they took like they based on their assumption, like based on their evaluation that that this score above this score is reasonable quality, and then below the score need to be kind of refined, right? So based on that, we have refined the. What we did is now we identified the samples that need to be improved in their translation quality. So what we did is we took those samples and passed to the LLM again, right, to improve the translation quality. So basically, what we do, we take the original English text, we give the translation, current translation, and also we give the score obtained, and we instruct the LLM to improve the translation quality. So we have seen that with this process of iterative translation. So we have seen that this kind of improvement, right? So the quality, and then we have done it in a couple of iterations to improve the translation. And what we have seen is even after doing these few iterations, we realized that the translation quality is not that great, or in the sense like some of the samples there, the scores did not improve even after several iterations. So to address this problem, what we did is that we took those some of those low scoring translations and passed to a doctor. So basically the native Arabic speaking doctors and native speakers to manually improve or refine the translations. So this is the overall pipeline we did to get a better quality benchmark. And the next thing is like so this is basically an example you can see here for the translation. We started with let's say English text, and then we have the first initial translation, what we get from the LLM, right? And then this is the initial, and then you can see the scores. We pass it to the LLM for scoring, and then based on the score, if the quality of the score is lower, we pass it again to the LLM for improving the translation quality. You can see that the quality is slightly improved, but then even after certain iterations for some of the samples, the translation quality did not improve. Then it went to the expert for further refinement formatting. So this is the overall pipeline. And as I said before, we have to introduce this multi-turn conversation capability for our LLM, right? So we to inject that to our LLM, we also introduced instruction sets like around 200K instructions, multi-turn conversation instructions to our LLM training, right? But how to get this multi-turn doctor-patient conversation data? So to get that, we again rely on LLM actually. So if you directly ask an LLM like ChatGPT to create this conversation, it probably hallucinate a lot, and the outcome of this multi-turn conversation may not be medically accurate, right? So we didn't want to take that risk. So what we do is we take the multiple choice questions from our training data, all right, and then pass it to an LLM, and prompt the LLM in a way that this multiple choice question is now converted as a multi-turn conversation between the user or the doctor and the patient. So that helped us to create nearly 200 K instructions with multi-turn conversation capability, and we have translated both these multi-turn conversations as well as the MCQ one from our training data to Arabic language to get our BiMed 1.3 million training data. So here you can see that we have nearly 800K instructions in the English and nearly 400K in Arabic. So in total of 1.3 million instructions, and we have a ratio of 2:1 between English and English and Arabic, right? So now we got the training data, we got the benchmark, right? The next step is to train them all, right? So how we take a Mixture model as our base architecture, and then we instruction tune the Mixture with our BiMed 1.3 million data. And to make our instruction tuning really compute efficient, we go for the QLARA-based parameter efficient tuning to reduce the computation requirement. So this QLARA adapters are attached to the mixture decoders and including the experts and the routing methods. So now we have started with explaining the training data. We have explained the benchmarks. We have also explained how we train the model, right? And with this training, we got a model that has English Arabic capability in the help of the healthcare application, and it has I told that the capability like multi-turn conversation capability and MCQ, good results on the MCQ-based benchmark as well. So let's see the results. Like this is on English, Arabic, and bilingual evaluation benchmarks. You can see that our model achieves really impressive performance in all these benchmarks. Like let's say, for example, in the Arabic benchmarks, it's also it has only 13 billion active parameters. It's really outperforms JAI's 30 billion model, while operating at multiple times faster in terms of inference time, right? And then it also outperforms the Mistral base architecture by a huge margin, thanks to our the BiMed 1.3 million instruction data set. Especially the gap you can see it's so evident in Arabic benchmark, Arabic healthcare benchmark here. And that's not only Arabic and English. We do really well on an English benchmark. As you can see here, we are the state of the art in among all the published healthcare specialized LLMs in English also. It's for example mid 42, right? It's although ours is a bilingual model, it's kind of performs well even compared to mid 42, and which is actually based on a 70 billion parameter, and we are actually operating almost 8 times faster compared to that model. But and at the same time, we are also more accurate even in the multiple MCQ based benchmark. And you can see that on some of the data sets like Augment QA, even we are better than the GPT-4, which is quite impressive as well. English benchmark. So now let me show you an example of scenario, to showcase the multi-turn conversation capability of our model. So we have so we pass the same question to state-of-the-art open source method like Meditron as well as our model, and we obtain the response from the model. Right, this is the response from the Meditron. You can see that it's not really engaging with the patient to dig deeper into the symptom, but this is the response from our model, right? So it's actually goes really deep into the patient's symptoms before it kind of comes to a conclusion, right? And while we pass this different open source medical LLM outputs along with the output from our model, our response was preferred by the doctors. And let me now show you some example use cases that we can use that can be done with our BiMediX. So we can use it for let's say summarization of the medical documents, including the research papers, to know the key highlights of it, or it could be even used for let's say medical report generation or report summarization in the hospitals, and also help you with hospital administration, like drafting an email that like maybe to get an approval for the insurance for a patient by also putting all the information or also gathering all the information from the patient records and placing it in the email. So this is one of the examples we tried our modeling. And then we can also use it for conversation with the patient, in different languages, like in Arabic and English language, as you can see here. And we can also use this kind our model for specialized or targeted applications, like say diet planning and giving suggestions on what kind of for the diets, right? Diet planning is kind of a huge potential for the model. And then we can also use it for counseling and mental health support as a virtual chatbot, to interact with the patient whenever they are really in need, right? So to summarize, our method or our BiMediX, you can see that uh, we come up with an English-Arabic bilingual medical LLM, which achieves state-of-the-art performance on English and Arabic and bilingual evaluation benchmarks, and it outperforms in open sourced state-of-the-art methods like Med42 and Meditron on English benchmarks, and it outperforms JAIS by almost 10% on Arabic benchmark evaluations, while operating at 4 times faster at inference, benchmarks. And it also outperforms like GPT-4 and GPT-3.5 on BiMediX dataset. And we have come up with, as I said, the evaluation benchmark, which we believe will be helping the future research in this direction with this kind of standard benchmark. And we also developed a 1.3 billion supervised medical instruction data set, which is actually bilingual English-Arabic, so which can also going to support the future development of healthcare specialized Arabic LLMs or bilingual LLMs. And apart from being good or being state of the art in this English Arabic benchmark, we are also good in our method is also shows its capability to study patient symptoms, which kind of shows its applicability in real world applications. So now we have this LLM that with English and Arabic capability, right? So we wanted to use it for the practical applications, right? So one of this is like we have integrated as a bot within Telegram, and we want to also make it so user friendly. So we have integrated the speech capability. So now you can talk to a model using Telegram app of your mobile, right? And then you can talk to a model in either in Arabic or English, right? And then you can get the response as an audio from the Telegram, right? So that's also again either in English or Arabic. So it's basically the same language as you ask the question to the model, right? Or you and then there's another feature we have integrated is that you had a conversation, right? And then you have after that, let's say the model is going to tell you that for your disease it's better to consult a doctor, right? Towards the end of the conversation, right? And if that's the case, the user can ask the model, can you suggest me a doctor, that's best suited for me? Because in a city like Abu Dhabi or in Dubai or even we have a lot of options in terms of specialized doctors, right? So it's very important to know which the right doctor to consult, right? Even within a specialization, there'll be some minor differences in what specialty each doctor is specialized, right? So based on the whole conversation the patient had with the model, and now the model, the LLM is looking, or our BiMediX is looking to the whole conversation, and then at the end it's going to suggest you a doctor who is in near to your locality, in your geographical locality, and matching with the symptoms that you have mentioned. So let me show you the demo of our model. Then we'll also show you if you are how to access our model, and then how to try it yourself.
No, I feel a pain in my chest.
You can select the language at first, English or Arabic. And
I'm
you can
sorry
talk
to
the
hear that.
model.
Can you please describe the pain in more detail? Is it a sharp pain or more of a dull edge?
It's more of a sharp pain.
I see. How long have you been experiencing this pain?
Can you help me find a doctor?
Of course, I can assist you with that. Please select the doctor option and I will help you find a suitable doctor in your area.
And now we can see that capability in Arabic language also.
مرحبا، أشعر بألم في رأسي.
أنا آسف لسماع ذلك. هل يمكنك أن تخبرني المزيد عن ألم الرأس الخاص بك؟
إنه ألم حاد إلى جهة اليسار.
هل يمتد الألم إلى أي جزء آخر من جسمك؟
كلا، إنه ألم في الرأس فقط.
هل لاحظت أي أعراض أخرى مع ألم الرأس؟
كلا، ألم في الرأس فقط.
حسناً، بناء على وصفك من الممكن أن يكون لديك صداع نصفي، ومع ذلك من المهم استبعاد أي أسباب أخرى محتملة. أوصي بتحديد موعد مع طبيب الرعاية الأولية الخاص بك لإجراء تقييم شامل.
شكرا.
على الرحب والسعة. إذا كان لديك أي أسئلة أو مخاوف أخرى فلا تتردد في طرحها، وإلا يرجى النقر على عند إنهاء المحادثة وتقديم ملاحظاتك.
So sounds good, right? So now, in case if you want to try our model yourself, like this is a live demo of a model. You can use this QR code or this to access our model, and then try it yourselves, and in either in English or Arabic, and let us know what you think about our model. And this is a set of instruction to how to use it. You can refer to that while you actually try it. And if you would like to know more about our model, please visit our project page. Here the links are provided, and then the research paper. To know more about the method, or even to see the video demo or even the Telegram demo. All the links are provided here for your reference. And also, if you have any questions, queries related to our work, please drop an email to me. Or we have similar or many more interesting works happening at MBZUAI, which I will normally keep posting in my LinkedIn. So please visit my LinkedIn to know better about my work and ongoing activities at MBZUAI. All right. Thank you.
Hi everyone, my name is Sara Piari. I was previously a master's student in computer vision at MBZUAI, and currently I am a research assistant. So during my last period, I got to collaborate with Dr. Hisham on the BiMediX project. That involved thinking about possible direction, cleaning data, as well as performing different experiments together with my colleagues. Overall, it was a very challenging project, but the exciting part was that I really got to know about new topics and being at the edge of AI and the technology and the progress we're making, it's marvelous. I really think that the impact that AI can have on science and medicine in particular, it's truly, truly promising. So, as a future direction for my personal work, I would like to include images into the pipeline. So, we can imagine medical scans or medical exam included to get an accurate prediction from these medical assistants. Thank you so much for being part of this amazing journey, and I really looking forward to see what amazing progress we can achieve together. Thank you.
So in the BiMediX project, my journey has been incredible learning experience. I got to play around and train models like mixture of expert models and adapt them for the medical domain, train and optimize them for the Arabic language and English language as well. One profound impact this kind of technology has in the future is that literally anyone with an internet connection can have access to this model and access quality healthcare right at their fingertips. So in future, we are expecting to extend these models to multiple domains, including pathology, radiology, and MRI images, and increase the potential access to these models for the entire world. Thank you.
Hello, this is Mohammed Irfan. For the BiMediX project, I was mainly involved in engineering-related tasks. So my primary task was to integrate a speech pipeline along with the current BiMediX backend. So we also have a Telegram BiMediX bot that is powered by the same speech pipeline. So in this bot, you have an option to select your preferred language, for example, English or let's say Arabic, and you can proceed with your chatting. So with this model, you can chat either with text or you can have a voice-based interface where you can send voice messages to the model, and model will also, the Telegram bot will also respond in either message or the voice as per your preference. So this is about mostly what I've been working on this project. Along with that, I was also exposed to working on different models and different model architecture. I got to know and learn how this model and architecture work internally and how a lot of different minor tweaks on the data sets can affect the sensitivity of these models. So actually, I have had a really good experience working on this project. One thing I'm very much excited about this project is that how it can be very much useful for healthcare professionals. Let's say this model can generate a diagnosis report of a patient in seconds, which usually takes around 5 to 10 minutes for a doctor to sit and type and document all those things. So this saves a lot of time for those healthcare professionals and actually allow them to focus on something more important. Looking ahead, I would like to work on multimodal models where user can interact with a model in different modalities. And along with that, I'm also very much interested in robotics domain where I can automate robotics using AI tools and technologies. So that's all about me.